Hello, everyone, and welcome to this re-recording of our research webinar for June. I'm Susie Roy, the Customer Relations Manager for the Americas and the Research Engagement Lead, and as always, the host for our SNOMED CT research webinars. Today, we're doing a re-recording. We will link to the original recording in the description box below. I really encourage everyone to go to the discussions, the Q&A at the end of that recording, which starts at the 49th minute at that YouTube video that's linked below, as that is when we start to have some really excellent discussion between Dr. Schulz and the SNOMED CT community. So let me introduce Dr. Schulz and have him do his presentation. So Dr. Stefan Schulz is a professor of medical informatics at the Medical University of Graz, Austria. He is trained as a physician with his research encompassing electronic health records, medical language processing, biomedical terminologies, and the application of formal ontologies for biomedical knowledge representation. He has contributed to the development of clinical terminology standards such as WHO classifications and, of course, SNOMED CT, where he is currently a member of the Modeling Advisory Group and the German Translation Group. Stefan Schulz has also has the role of Head of Medical Research Projects at Avribies, a German language engineering company. Today, he'll be presenting, is SNOMED CT an appropriate reference terminology for mining electronic health records? With that, Dr. Schulz, I'll let you take over the screen share.
Yeah, thanks for your kind introduction, Susie, and yeah, welcome everybody to my re-recorded webinar, where I even extended a little bit the title. It's now, is SNOMED CT an appropriate reference terminology for mining narrative content in electronic health records? So the focus is really on narrative content in EHRs. And of course, this is an extremely broad field, so it would deserve a whole course. And so I need to focus on very basic things, because NLP, natural language processing, is really an area with many scenarios of use, from machine translation to question answering and so forth. And here I will really uniquely concentrate on what is also known as text understanding. So that means that I'm trying to address and discuss the appropriateness of SNOMED CT, and not SNOMED CT alone, but mostly in concert with HL7 FHIR as an information model, for kind of understanding clinical narratives by transforming their content into fine-grained, precise, context-aware, unambiguous, and standardized representations. So that means that ideally, if this really works 100%, which probably will never happen, but of course we will try to get close to that, that then the target structure is really a set of instantiated FHIR resources with terminology bindings, which really represents clinical content as if it were entered by structured data entry. And so the focus is on text understanding, encompassing both ontology and terminology aspects of SNOMED CT, placing SNOMED in an information model, talking about entity normalization, semantic phenomena, particularly also relation extraction. As you know, I'm from Austria and Germany, where we have our EHRs in German language, so multilingual aspects are also important. And I also will talk about the construction of resources for training models to support text understanding. And I blind out as much as I can everything which really would be kind of an introduction to NLP, because I I think that many of you have perhaps this knowledge, and for others, I think at least those examples I will demonstrate, I think make it understandable also for people not familiar with NLP technology. So, sorry, yeah. Clinical NLP focuses on clinical language, and clinical language is really different from medical language or biomedical language, the language of textbooks, of scientific papers, simply because it is really produced under time pressure, and it's also meant to be read really by people, by colleagues, by physicians, by nurses who more or less share a very similar context. And therefore, clinical language is compact, is sloppy, and is contextualized. And this encompasses a lot of phenomena like this telegram style. So you often do not find full sentences. You have a lot of colloquialisms, which you probably would not write in a textbook. Often you just stop writing when you have the impression that everybody understands the word, even leaving out some characters. Then short forms often depend on the context. For instance, RTA, in one context, it's road traffic accident. In another context, it's renal tubular acidosis. Then often short forms are only understandable in a local scope, even if something like, for instance, LDS could also be understood as leak detection system in another context. This is not a problem really for humans and our, let's say, human-like dealing with language, but it's a real challenge for machines. Not that much as it used to be, but still a big challenge, which is hopefully better and better addressed by artificial intelligence, particularly text mining, machine learning technology. Yeah, then you sometimes have numeric codes, for instance, this stands for teeth, or this is a dosage scheme for drugs, which is only used in Europe. Then, of course, the quicker you type, the more you commit spelling errors and typos. Also, often the people who produce clinical documentation are second language speakers. Then there are the known spelling variants. Then in some languages, like, for instance, the German language, we have the tendency to glue together several words. And then we have also one phenomenon, and I will explain this a little bit more because I will come back to that, which is called anaphora. Yeah, for instance, you introduce something in a lot of details, an adenocarcinoma in the rectum, and then a certain TNM code, and then you tell something else, and then full stop, and then you write tumor excised in toto. So tumor, of course, can be many things, but the important thing is that this word tumor is recognized to have a referent, which is not just a tumor without any further specification, but it is exactly this here as a referent. Yeah? Or if you have no blood in stomach, blah, 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 and then multiple mucosal erosions, that this is not the nasal mucosa or some other mucosa, but this is this mucosa of the stomach. So you need to create a lot of links in order to understand particularly that kind of compact language. Yeah, those links we do automatically as long as we have really been at medical school. Otherwise, it would be also not understandable by let's say non-medical people. Yeah, then we have a lot of negations. Sometimes you have sorts of documents in which 80% is just negation. Yeah, and there are many ways to express negation. And then you have those so-called epistemic contexts which express uncertainty or hypothesis. For instance, here a suspected MI, differential diagnosis, lung embolism. And this is in order really to understand this text, is very important that this is not really a fact. This is still a hypothesis. So I think if you, let's say, for epidemiological purposes, want to count the occurrences of lung embolisms, you should not count that because it's just a differential diagnosis. Yeah, then temporal contexts, history of or a certain time stamp and other contexts like family history or plans not executed. So this is really very typical for clinical language. And I think now you understand why, let's say, training language models with other medical texts, such as publications, in many cases are not very helpful to understand this kind of language by machine. So sometimes there's a discussion, will free text documentation become obsolete? And I would say probably not. The reason is that the way how we communicate is by human language, and particularly clinical language is a highly optimized tool for interprofessional communication. And so I don't think that natural language documentation and communication will disappear as long as healthcare is delivered by humans. Perhaps if there is a large shortage of jobs for clinicians, currently it's the other way around, but then you can really require require that a clinician really only enters structured data in order to get a job. Then maybe he or she will move away from free text documentation, but I think this is not realistic. As long as such a clinician really then argues, well, sorry, but I won't work in a context where the computer is not able to understand my language, and where I have to adapt to the computer. This was normal in the past, but I think nowadays with so many gimmicks around us, with mobile phones understanding human voice, and so it's less and less acceptable that doctors or clinicians, nurses are forced to the traditional way of data entry. And structured documentation is often, when natural language documentation is required anyway, then structured documentation is often seen as redundant and sometimes error prone. If, for instance, the clinicians don't care about the correctness of the ICD codes because they know that what they have written in the report is more precise. And as I said, speech interfaces are getting more and more popular, and so language-centered way of human-machine interaction. I think this is for the new generation, those who are now in preschool age, probably it's will be the most natural thing of the world that they will speak with the computers. And therefore, I think the barrier to human-computer natural language interfaces will get lower and lower. So these boundaries will disappear, and nevertheless, it requires a highly sophisticated technology, namely language understanding, which only works with good resources, namely, on the one hand, semantic standards, which is provided by SNOMED International, by HL7, and by other communities, and also language models. And language models really require real clinical language, which is really a problem to get hold of because of privacy concerns. I will come to this later. So the remainder of my talk is structured as follows. So I call it a journey from text to structure. So we have the clinical narratives, and we have to move up and down and overcome many blocks in the road in order to really end up with a fully standardized structure, interoperable or fair representation of clinical content. And I have divided it into 4 challenges. So the first one addresses the terminology side of SNOMED, also with a focus on multilinguality. Then the second one focuses on the ontological part of SNOMED, where it's about semantic enrichment and disambiguation. And then I will talk about the need to have really principled guideline-driven target representations. And finally, I will address some pending issues in SNOMED CT, which should be resolved in the future to improve its usefulness for NLP. So I'm starting with the representation of multilingual clinical sublanguages. So the problem of dictionary coverage is obvious when you remember those examples I gave you, that there are really lots of words and expressions of really very limited use, and which are normally not in medical lexicons. And I participated some years ago in a European project called Assess CT, or Assessing SNOMED CT as a terminology for Europe. So it was also really the focus on localization, on multilingualisms. And one of the recommendations of this project was that so-called interface terminologies should be created for linking clinical content, clinical terms, but really clinical terms in the sense of clinical jargon terms to SNOMED CT. And we did some empirical assessments, and what was really interesting, we built a parallel corpus of 6 European languages, and we used this corpus in order to benchmark coverage of SNOMED concepts and SNOMED terms using or collaborating with experienced coders from different countries. And so, for instance, it's very obvious if you compare English to Swedish, and in Swedish we have only 1 term per concept translated. In English we have on average 2.3 terms per concept, whereas the concept coverage is the same more or less. Yeah, the term coverage drops dramatically for Swedish just because there's only 1 term per concept. Although English has a much richer vocabulary than Swedish, but it's obvious that it's just not sufficient what the Swedish translation of SNOMED CT, and probably it would also happen with other translations of SNOMED CT, which translated only the preferred term, offers for clinical language understanding. And this also motivated me to start some years ago with the building of a German interface terminology for SNOMED CT, using a very complicated workflow combining human and machine translation, concept mapping, and term generation, particularly those very long agglutinated terms which abound in German clinical language. So they are they need to be really represented in an interface terminology, and so I build them automatically following a set of rules. So this I cannot go this deeply into this, but this shows the production workflow. And currently we can say that at least against this benchmark, which also comes from Assess CT, we have a very similar performance between the English SNOMED or the whole set of SNOMED terms in English in the international version, and of this German interface terminology. But also, what is important also regarding what I'm going to tell you later is that we have a very low inter-annotator agreement in the reference standard, so that there were really lots of disagreements between the annotators, and it was not this agreement was not different between SNOMED and SNOMED free UMLS extract, which we used as a benchmark. And so this is perhaps also something which we should expect, that SNOMED provides more support for avoiding disagreement between annotators than, let's say, a kind of meta thesaurus, which has no, let's say, no definitions and so. But anyway, this is still a real problem. That with such a huge terminology, you have often several options to express the same thing. Well, so summing up the aspect of clinical vocabulary representation, which has some open issues, which is mostly the manual creation and maintenance of such a resource, and which really is prohibitive to cover everything, because human language, and particularly clinical language, is so productive and so really productive in new collocations of words, in new abbreviations and other short forms, that you cannot really cover everything. You perhaps could improve the coverage by including the community in a kind of crowdsourcing process, but this is just a hypothesis. Nobody has tried it so far. And then, of course, we should leverage the whole potential of machine learning in order to detect synonyms or terms with spelling errors, to resolve short forms, to ambiguous terms. But again, this is only possible if we really can train our models with large amounts of clinical data, and this is a real bottleneck. But then the question is also how to exploit SNOMED CT's axiomatic structure. And for instance, currently a PhD student of mine is trying to generate all kinds of paraphrases out of the axioms for fully defined concepts, and to populate an embedding space. And we will test this against the I2B2 benchmark in order to find out whether this is a way to improve the recognition of, well, all kinds of variations of clinical language. So coming to the next point, which looks quite deeply in the ontological or axiomatic structure of SNOMED. And here is just an example which catches up with this, what I told you before about an FHIR. So we have here pilaris and superior duodenum, which is somewhere here, edematous thickening, which a radiologist can identify that the walls of these segments of the gastrointestinal tract are thick. Yeah. And then the conclusion suggestive of ulcer. So we have a very, very simple sequence of sentences, and I think for whoever has a certain basic knowledge of medicine, it is really trivial. So the problem is what happens with a, let's say, naive approach to text mining or entity normalization. Yeah, of course, you identify words which are in your dictionary, then you identify, so, well, the theory behind is that those words, they have reference, the things the words point to, in the real world. And these references then can be linked to codes in a coding system, such as here SNOMED, and you have here pyloric structure of stomach, you have structure of superior portion of duodenum, you have edema, you have thickened, you have suggestive of, you have ulcer. Yeah. The problem is that such a sequence of SNOMED concepts is really not sufficient, because what is the reason why we understand this text? We know that there is a relation between edema and duodenum or stomach. We know that thickened is a quality which inheres in those anatomical structures. And we also know that, for instance, ulcer, there are so many ulcers, yeah, from the cornea to the toe, yeah, we can have ulcers at many locations, yeah, and so therefore ulcer disorder is just a very useless concept here, yeah, but it's not useless for us because we know that, yeah, it refers to something which refines it. For instance, here pyloric structure, yeah, or here structure of superior portion of duodenum. And the interesting thing is that we have pyloric ulcer also in SNOMED CT, and given that pyloric ulcer in SNOMED CT, yeah, is fully defined, it has the relation finding site pointing to this here pyloric structure of stomach, and therefore we can really refine ulcer to pyloric ulcer. Yeah. And this is what is called relation tagging, so that we really we are not satisfied with just the tagging of the entities, yeah, where we sometimes have very general things and without any relation to other things, but where we really weave a closer web of knowledge here. Yeah, the same, for instance, also of duodenum. Yeah, and then also, for instance, here we know that from SNOMED that structure of superior portion of duodenum is a subclass of duodenal structure, and therefore, if this is of this type, it's also of that type. Yeah, and then it also allows us to refine ulcer to ulcer of duodenum. So, and this is really something which really still needs to be fully explored, namely SNOMED CT's ontological structure for what I call annotation refinement. And this is really a case of symbolic reasoning. Symbolic reasoning in the past years was a little bit eclipsed by all the fancy neural network stuff, but nevertheless, it's an extremely rich source of knowledge, and as I have shown, it can really be used, for instance, that from the SNOMED concept model, yeah, we know that if type 1, if the entity instance I1 is of the type clinical finding, I2 is of the type body structure, then normally what is expected to hold between those things is finding site. Of course, the problem is then if you have many findings and many body structures in your text, then how to really know which are related to which. And well, this is also something we really have to find out using simple heuristics, perhaps just to take the first to the left, yeah, but also to train models in which a machine learning model suggests relations, yeah, which is an important part of natural language processing research, is really to automatically assert relations in texts. Yeah, and then from those templates, you can find a new type for the instance, so that the ulcer, which is related to the duodenal structure, what we found out by these relations, is then of the type ulcer of duodenum. Based on the axiom ulcer of duodenum equivalent to ulcer and finding site some duodenal structure. A bit simplified without role proof, but this is not a problem. Then here, another very, very common problem in language understanding, which is called word sense disambiguation. And this is a German language example, which is very, very, very easy to understand. That this here means, well, what hot water does with your skin. And here, Blase, it is a word which can mean bubble, blister, bladder. And you imagine here it could be blister and could be bladder. And so we need to disambiguate it. Of course, there are several ways of disambiguation, also model-based disambiguation, but also here we should not forget that also the internal wiring of SNOMED CT affords us with an important resource for disambiguation. Then, for instance, here we same procedure as in the other example. This here is hot water burn of skin, and then this here could have two referents. It could be have a blister of skin or mucosa as a referent, or it could have the urinary bladder structure. And then if you then just follow the path which are in SNOMED CT, which are essentially what's in the relationship file, or which is, well, if you translate it into OWL, which constitutes all these OWL axioms, but for instance, you see that this here, blister of skin, also goes to structure of skin, and here finding site some skin structure also, which also is a specialization of this here. And so this really suggests that this here is the right meaning of Blasen, because if you try to find a path from urinary bladder to structure of skin, it won't be so straightforward, certainly. So, and therefore you can discard this here. So then there are other ways to disambiguate. For instance, if you have this here, normally you need this here, your liver is out of function, and then you need a liver transplant, and really something like this really can show up in clinical documents. At least here in Austria, sometimes clinical documents look even worse, or problem list entries or things like that. So what does it mean? Liver transplant, this is the name of a hospital, Arkansas Department of Health, by Dr. Parkinson due to BPC, primary biliary cirrhosis. So I think who deals with livers and transplants normally will understand this. But let's say a simple approach to text understanding just by concept matching provides really a lot of fatal results. For instance, LT will be looked up in the lexicon as transplantation of liver, fine, but also Leishmania tropica, which is an organism. Or ADH, which is the name of a hospital, would be anti-diuretic hormone. Or Parkinsonism, or PBC could be primary biliary cholangitis, which is the right concept, but it could be also positive blood culture. And so this is really a big problem that due to ambiguities and sometimes also idiosyncratic abbreviations or eponyms where diseases are named after after doctors, you get a lot of really wrong hits. So that the precision of this representation is very bad. And so what we can really use here is a very established technique of natural language processing, which is called named entity identification. So what we did before was entity normalization, but named entity recognition just gives you the semantic type, yeah, for instance, procedure. And yeah, having a procedure here, then you can already discard the reading that it's an organism. Or here, state, well, you need other mechanisms to deal with states. Then this was identified as a location, and then it's clear that it does not mean anti-diuretic hormone. Parkinson, Dr. Parkinson is identified as a person, and so we also avoid this wrong interpretation. And then if PBC is a condition, then or disorder, well, finding could also be a disorder, but if the tagger makes a distinction between, let's say, disorders and other findings, then also you could discard this here, and then you really have only that what represents what you want. Yeah. So that shows you that natural language processing really provides you with also a toolkit of so many different tools and approaches, and there's a lot of software packages which are in the public domain, such as Spacey, and many very cool things. So which makes it a lot easier than it used to be, let's say, even 5 years ago. Yeah, but there are still open issues with semantic enrichment and disambiguation. Yeah, for instance, which entities qualify as candidates for which relator? So the question, which is a salient entity, which is, for instance, an anatomical term, which is really needed to refine a condition like ulcer. Yeah? So there are a lot of theories also from linguistics. For instance, that you look backwards, but then you can really here do several PhD theses just about anaphora resolution in clinical text, definitely. So I hope that I will find PhD students to work on this. But also, you should also not forget that what is more or less well known with language models, where you use neural networks to train language models, that you can use similar concepts also for so-called knowledge graphs, so that you train a model with a kind of a graph which links knowledge entities together, and an important goal of such knowledge graph models is what is called link prediction, so that really those relations can be predicted out of a well-trained knowledge graph. Yeah, but also to align these technologies with knowledge which is encoded in a SNOMED concept model. So then, going to the next point, namely principled guideline-driven target representations. And I already mentioned that even with a kind of basic, not very well elaborated guideline, and using the guideline by really people familiar with clinical coding, we got very bad inter-annotator agreement results. So this is definitely something to work on. Yeah. And just one example, which is called logical polysemy, and which is really an issue in SNOMED, is, for instance, something like that. We have palpable fissure, yeah, equals 12 millimeter. So the problem here is that in SNOMED, we find 4 different concepts for this: structure of palpable fissure, entire palpable fissure, palpable fissure observable, finding of measures of palpable fissure. So which one to take? Well, here perhaps the answer is very straightforward, because this is something which is completed by a measurement, and therefore you have to take here the observable entity. But sometimes you don't find observable entity, for instance, because the observable entity hierarchy is really not very complete, probably due to unresolved issues with LOINC. So that sometimes if you have something here like potassium in serum or something like that, you don't find an observable. You have to take another one. And also you have for the body part concepts, you have those body structure, that you have those structure of or entire. Which also you have to have a guideline when you should take which. Yeah, and this is really a problem in SNOMED, but also in other terminologies. But it's really not word sense disambiguation. It's not the normal polysemy where you have ATR as what was it? No, what was RTA, road traffic accident, or renal tubular acidosis, or in the German one, where Blase is blister or bladder. Here, really, you have things which are conceptually related, and they are conceptually related, not always explicitly. Unfortunately, observable entities are normally not related to the concepts they should constitute them. But nevertheless, you have several options. Yeah, and this is, you find this everywhere in SNOMED. Yeah, for instance, here the entire anatomical entity or any part of its structure versus entire disorder as a clinically relevant occurrence versus a morphological structure that characterizes it, observable or a grouper finding concept, then body structure observables, pharmacological substances versus products that contain that substance, foodstuff, like for instance fish, yeah, or the biological organism the food is taken from, and so on. So, and this is a real problem, yeah, that you give an identical text to two annotators and without very, very fine-grained guidelines, and also the willingness to apply them, both annotators probably will come up with very, very different results. Yeah? But we need certain guidance for a detailed description, yeah, of such a principal target representation. Yeah? Especially if we use, we want to use SNOMED consistently within clinical information models. Yeah? Because what we really want is to identify that two things mean the same, even if they are perhaps structurally different. But we should reduce this to the minimum. Yeah? So ideally, one canonical representation of all paraphrases of the same clinical content, or several representations that are computationally equivalent. Yeah? So here, just different instantiation of condition. Yeah? For instance, here suspected gallstones. Yeah? There is one code. Or here gallbladder calculus and verification status unconfirmed. Or calculus finding, and then you have the body side structured, and so on. And this is a really a huge problem. Yeah? You have those standards, but you have no interoperability due to competing semantic representations without any possibility to identify that they are equivalent or very close. Yeah? Maybe neural network technology will help us to compute also the semantic distance of those different representations. But for this, you need really, millions of instances of such training data. Yeah, this is just something I have started producing an annotation guideline for clinical narratives using SNOMED and FHIR. And we are using Inception as an annotation tool. And you see here, for instance, here we have a negation of no mass, and we have here, for instance, mass, and we use verification status from FHIR condition to relate this to refuted, yeah, which is the way how we express negation. Yeah, but this is still in a very early stage. And fortunately, we got huge funding from the German Ministry of Health, where in my job in Germany, I'm directly included, and in my Austrian job, I contribute. And the goal is to produce an open annotated corpus of clinical documents that represent really a broad range of texts for which we have informed consent by the patients. And the annotation guidelines we want to establish should follow the ontological structure of SNOMED CT and FHIR. At least and here, this is a kind of preliminary task for this. And one very basic principle is, and maybe the SNOMED community would not fully agree with this, but I tell you what is at least currently, which seems reasonable to us, that we use FHIR as much as we can, and only what is not expressible with FHIR, of course, it's a lot, it's the whole terminology, but only for the terminology proper, we use SNOMED, which for instance means that we do not use at all the SNOMED context hierarchy, situation hierarchy, because this is just an alternative way to express context. But here, for these annotations, we want to express context by FHIR structures. Yeah, and therefore the boundary between SNOMED and FHIR, yeah, is another area which really requires a lot of work. There has been, well, yeah, just the theory behind, and this is a important paper. I always give my students that paper by Rakul Kumar and Alan Rector, which very clearly makes this distinction between information models and terminologies or ontologies. They coined this pair of concepts, namely model of use for information model and model of meaning for the ontology. And there has been a lot of work in the so-called term info initiative, which unfortunately ended around that year when really FHIR took off. So I don't understand really why this has been discontinued. But perhaps it could really be, I think there are many reasons, especially now when FHIR is really established worldwide as, I would say, information model #1 for the clinic, to resume this work on really defining the boundary between SNOMED and FHIR. For instance, we have something like this here, suggestive of ulcer. Yeah, and from that previous example. And of course, we have here, for instance, suggestive. You can express with suggestive of with an attribute, but also we can use here FHIR and unconfirmed in FHIR condition. Yeah, which then would be an value, yeah, of the attribute verification status. And then here in category then goes pyloric ulcer. Yeah, here goes the clinical concept proper. Yeah? But everything else, including dates and informers of certain signs of a patient, severity, and those really subjective things, they are really represented by HL7. And the question is, I think it's also something which is currently being addressed and discussed by the SNOMED FHIR group, to what extent the value sets here, for instance, for verification status, should really be enriched also by SNOMED concepts, because sometimes these FHIR value sets are very small. and not perhaps really expressive enough for really representing content of clinical data. Yeah, so this is just what I said, our workaround, represent everything in FHIR that is possible, exclude this SNOMED situation hierarchy and certain redundancy, for instance, body side, which is also a slot here, body side, and of course you can express it in SNOMED, often it's already included in the, or mostly it's included in the finding disorder concept. But here, let's say some kind of redundancy wouldn't make any harm. Yeah, here to a reference I really recommend to read. They are quite old, but are really quite similar references. Yeah, so I'm coming to the end, and I will talk about some pending issues in SNOMED CT affecting its use for NLP. So one problem is that we have quite a number of very similar, potentially overlapping and completely undefined concepts in SNOMED. For instance, this here. And this is really a problem because we do not often know what it really means. And this also surfaces whenever you start translating SNOMED into your own language. And I'm a member of the German translation group, and it's very problematic to find the right terms, because sometimes you have different concepts. You would say, well, isn't this the same? Yeah, and then you try to find out which are the boundary, but SNOMED does not provide help, because you don't have formal definitions and you don't have text definitions here. Yeah, or then you have concepts defined by labels or identified. They are not even defined. They are characterized by context-dependent labels. But then, according to the context, it means really different things. Yeah. For instance, here, what is an adolescent? Yeah. Whatever source you refer to, provides you a different definition. I think this I did once for a talk in France, where I also looked at French sources. But really here you have 12 to 21, WHO says 10 to 19, or here in France it's between 12 and 18, and here it depends on certain physiological phenomena like puberty. Yeah, and so I would say that such concepts are really not very helpful. Yeah, and the question is whether perhaps you should have several concepts for this, but not defined by such a fuzzy name, but by intervals of years. For instance, 12 to 21, and another one person 10 to 19, and you could still have adolescent as a synonym. Yeah, or then other things. This here I call the lonely wheelchair. You have an impressive amount of wheelchair-related concepts in SNOMED CT. Of course, you have the wheelchair device, and you have many other things fall from wheelchair, does not perform wheelchair transfers, difficulty transferring between wheelchair and toilet. Very, very important concepts, especially for nursing, and for all branches of medicine which deal with disability. If you look into the internal wiring, let's say in the ontological relations, including wheelchair concepts, it's really disappointing, because you only have those two links. You have provision of wheelchair, which really has wheelchair as a direct device. You have wheelchair maintenance and repair, which also have direct device wheelchair. But you have 109 concepts with wheelchair in the name, but which are not linked at all to the concept wheelchair device. Yeah. And so certain recommendations I would dare to issue regarding this these SNOMED concepts with overlapping meaning or just underspecifications. Yeah. So that really, for the better use of SNOMED in NLP, and this is especially important for NLP because NLP means annotating resources by SNOMED concepts, yeah, by humans and finally by machines. And consistent results you only get if you really have a clear criteria which concepts to choose. So one recommendation is you should formally define or describe it. Yeah, but of course many SNOMED concepts cannot be formally described. But then add text definitions or elucidations, and I think ICD-10, yeah, at least in the mental disorders chapter, it shows how it could look like, yeah? To have a very clear definition what is anxiety, what is an anxiety disorder. But maybe you do not need to just to mimic this in SNOMED CT, but you could link to authoritative text definitions. Yeah, maybe there is a IP issue, no idea. Yeah? But also you could link to other sources, images. Yeah, you have Wikimedia images you could link to in order to, for instance, to demonstrate that the concept heart means something of which the pericardium is part of, which, for instance, an anatomist would not agree. Yeah? For an anatomist, the pericardium is kind of envelope. For a surgeon, the pericardium is part of the heart. But if you have the concept heart, I would say it's very important to point what is really meant by that. Yeah, and standards require more than just labels and hierarchical links. I think that probably everybody agrees. And my experience is also what is ill-defined will be ill-translated. And this affects the usefulness of SNOMED CT in cross-language scenarios. So I'm wrapping up. I can clearly state that for the purpose of NLP, SNOMED CT is already a highly useful resource due to its conceptual coverage and granularity, its ontologically grounded categories and relations, and its formal axioms. But as a terminology, it cannot be expected to represent idiosyncratic clinical jargon. Yeah, it is called SNOMED CT. CT means clinical terms, but real clinic for good coverage of real clinical terms, language groups, user groups need to create and maintain interface terminologies and link them to SNOMED CT. It's definitely not the business of SNOMED International to provide millions and millions of clinical terms for each language. This is really, this should be up to the users. Also, this is extremely dynamic because clinical terms, even new words for the same thing, are created, are coined every day. Yeah. But of course, the coverage is never complete, and so we need mechanisms for fault-tolerant entity normalization. Then, really interoperable representations require in-depth annotation rules. Yeah? And these annotation rules are not trivial. And annotators really need to incorporate these rules. Annotators, before really annotating clinical text in a good quality, need to go through several webinars and being coached by experts to really produce good annotations. Yeah. And it's important, especially for relation annotation, to have a set of canonical relations compatible with the SNOMED concept model. I also should add also compatible with FHIR and FHIR attributes. and also ontological principles. It's also important that, and it's something close to my heart, that SNOMED should reassess itself more and more under really good practice ontological principles. Yeah, and precision medicine needs precision standards. Everybody talks about precision medicine, and well, SNOMED is a standard with, in many parts it's very precise, but in other parts it really needs to be improved in terms of precision. Yeah, there are still too much underspecified and fuzzy concepts in SNOMED CT, which is difficult for annotation, difficult for interface term mapping, and particularly cross-language. Yeah. So one desideratum would be to specify the content of SNOMED CT, concept description by addition of textual definitions. And finally, clarifying the boundary between SNOMED CT and FHIR, preventing the proliferation of incompatible annotation patterns. And this is my last slide. So the desiderator for the NLP, the previous was for SNOMED, and the desiderator for the NLP text mining and AI communities produce and publish annotated corpora, clinical annotated corpora, and language models, and to publish them, to really make them available for the community. Yeah, and of course, this requires a legal and ethical framework that allows the use of clinical texts as training resources. Yeah, informed consent given by patients is already a very big step for that. Yeah. Then following standards and ontology principles when developing annotation schemes for clinical content. So I think it's really, compared to what has been done in the past, which often used categories which were not very principled, making a distinction between sign, symptom, and disorder and diagnosis, and often with very fuzzy boundaries. So it is important to really follow those standards also for the annotation schemes. Yeah, and finally leverage the potential of knowledge graph technologies and optimize deep learning technology, including machine translation for accelerating the acquisition of translations and synonyms. And probably I could give you some more, but I'm at the end of my talk, and I hope that you learned something, and I'm very happy to answer questions. Just emailing me to Stefan Schulz at medunigraz.at. Thank you very much.
Excellent. Thank you so much, Dr. Schulz. And as he mentioned, his email address is located on the slide. I can be reached, again, I'm Susie Roy. I can be reached at sro@snomed.org. And Dr. Schulz, thank you so much for redoing this presentation so we could record it. As mentioned, we have the original recording with all of the rich discussion and Q&A on our YouTube page. If you go to the description box at the bottom of this this video, you will see a link to that other presentation, the original one. And if you wanted to skip ahead just to the Q&A and discussion, go ahead and move the cursor to the 49th minute of that presentation, and you can hear our discussion. And with that, Dr. Schulz, thank you so much. Thank you all.
Thanks for inviting me. It was a pleasure, and I hope it will be useful for some people.
Oh my goodness, absolutely. And I will ask you in another year or so to come back and update us. So, you know, third time will be the charm.
Okay.
Awesome. Okay, I'm going to stop this recording. So one moment.